Hey guys, it's Miss Johnson here, and I'm here to bring you our video for graphing quadratic functions, the first lesson for our unit on quadratic equations. So we're just first going to talk about how to graph those functions. The example up at the top of your page says, rock music managers handle publicity and other business issues for artists they manage. One group's manager has found that based on the past concerts, the predicted income for performances is that equation right there. P of x is equal to negative 50x squared plus 4,000x minus 7,500, where x is the price per ticket in dollars. Now, this is a quadratic function, and the reason this ends up being a quadratic function is right there, because we have an x to the second power. X to the second power tells us that it's quadratic. Okay. Now the question is, what happens to the income as the ticket price rises? So if we take a look at the graph that they've graphed this function for us, and we want to look at what that graph tells us. So here we have income down at $0, where the ticket price is $0. And as the ticket price increases, the graph goes up. And then there's a point right here that seems to be at about $40, where that ticket price turns and then goes back down. So that's what's happening here. The income increases until the ticket price is $40. Then it turns and goes back down. So then it decreases. Okay, and we can see that there because of the graph of the quadratic function. Now, one thing about these graphs is that notice that this is not linear. This does not make a line. This makes what we call a parabola. Okay, that's a parabola. So let's just take a look at quadratic functions. It says a quadratic function is a function in the form of f of x equals ax squared plus bx plus c, where a is not equal to 0. So we have to have this power of 2. We have to have a squared term. Okay, and x to the second power, or power of 2. And this is the graph. This is what the graph looks like. One thing that we should note is that the y-intercept is c. The y-intercept is equal to c. So you can go ahead and write that down on your notes. The x-coordinate of the vertex is this right here. X is equal to the opposite of b over 2a. So I would write that down. The x-coordinate of the vertex is x equals opposite of b over 2a. You have that written there. It might be a good thing for you to go ahead and highlight that. You know, good. Highlight that bad boy, because we're going to use that a lot when we graph these quadratics. You're actually going to use it a lot throughout the whole quadratic unit. So, and then the vertex uses this opposite of b over 2a. It's also giving us where the graph changes direction. The vertex tells us where the graph was decreasing, turns and increases, or vice versa, was increasing, turns and decreases. So that's where we get minimum and maximum values. If we have a quadratic function that opens up, okay, this is where we have an a value that is positive. So this is a quadratic function that opens up and it has a minimum value. Okay, a is positive there. When a is negative, that's the first term, or less than 0. When a is negative, that's when the parabola opens down and has a maximum value. Okay, so a positive a tells you that it's an opening up parabola. A negative a tells you that it's an opening down parabola. And that's the coefficient of the x squared term. Okay, so that's whatever's in front of the x squared term. What is this number? Okay. let's take a look at our first example. Our first example says we want to consider the quadratic function and find the y-intercept, find the axis of symmetry, and the coordinate of the vertex. So let's look at the function. It says g of x is equal to x squared minus 6x plus 3, and we want to find all of those things. What's the y-intercept? What's the vertex? What's the axis of symmetry? The y-intercept is easy. The y-intercept is where we have c, or in other words, it's where x equals 0. Remind yourself that if you've forgotten what y-intercept means, where x equals 0. So if you consider plugging in 0 for x, I'd have 0 squared minus 6 times 0 plus 3. That goes away, and you're left with positive 3. That's why our y-intercept is considered 0, comma 3, or in other words, up 3 on the axis. So there's our y-intercept, okay? The vertex is the one that we really want to think about because the vertex is more telling to us. The vertex tells us the middle of the parabola. So let's think about how to find the vertex. To find the vertex, I want to first find the x-coordinate. So this is for the vertex. I have x is equal to the opposite of b. B in this case is negative 6, so the opposite of b would be positive 6, and then over 2 times whatever a is, which in this case is 1. That's 6 over 2, which is 3. Now that's only the x-coordinate. I also need to find the y-coordinate of the vertex, so I need to plug that back into my function. I'd have 3 squared minus 6 times 3 plus 3. That's 9 minus 18 plus 3. That's negative 9 plus 3, which is negative 6. So here's the x-coordinate, here's the y-coordinate, the vertex is 3, negative 6. That is the more telling point. That's a really good point for us to know, 3, negative 6. And it's helpful to even note that on the graph, that's your vertex. Okay. What that also means is that the line, the vertical line that goes through that point is the axis of symmetry. That's where the graph is the same on either side. Okay, so I know that my parabola is going to, the left half of my parabola on that side is going to look the same as the right half across the axis of symmetry. The axis of symmetry goes through the vertex, and that's like the middle of your parabola. That's a really good thing for us to find. So the axis of symmetry is where x is equal to 3. Okay. So then let's figure out how to graph the rest of this. We could consider this point right here. The y-intercept is very useful to us because at the y-intercept we're 1, 2, 3 units from the axis of symmetry. So let's go 3 units in this other direction, 1, 2, 3 units. Since it's symmetrical, I know that I'm going to have a point right there. So now I can connect those two, and remember it's not linear, it's not a line, it's a curve. So there's my parabola. That's enough to graph a rough sketch of the parabola. Let's take a look at the next one. In number 2, I want to consider the function f of x is equal to 4x squared minus 8x plus 2. Now, again, the y-intercept is the easiest one to find, that's for sure, but it's definitely not the most important. The most important is going to be the vertex. The vertex is going to tell you that middle. So if I look at finding the vertex, okay, the x-coordinate is going to be the opposite of b over 2a. Opposite of b is negative 8, so the opposite would be positive 8 over 2 times 4. That's 8 over 8, which is 1. Then I need to plug that back in and get the y-coordinate. The y-coordinate looks like 4 times 1 squared minus 8 times 1 plus 2. 1 squared is 1 times 4 is 4. Minus 8 times 1, which is 8, plus 2. That's negative 4 plus 2, which is equal to negative 2. So the vertex there is going to be 1 comma negative 2, which means our axis of symmetry is at 1. So 1, negative 2, that's my vertex right there. And again, that's going to be probably the most telling point. Draw in your axis of symmetry. That tells you, sorry, I didn't do a very good job making that a straight line. That tells you where the middle of the graph is. That tells you where the parabola increases or decreases on the other side. So then The y-intercept is 0, 2. That's a good thing to know as well. I can use that y-intercept, mirror image it on the other side. I'm 1 unit away from the axis of symmetry, so I go 1 unit in the other direction, and there's my graph. Connect the points. Again, it's not a linear equation, it is a curve. It's a subtle curve, but it's there. Okay. I'm going to go ahead and stop our video at that point. We'll come back and finish off the last 2 questions in class tomorrow. Thanks for watching. Don't forget to go back and watch your Schoology quiz, and have a great night.